Welcome to the DIY Honda Garage channel. This presentation focuses on Diagnostic Trouble Code P1708, indicating a high voltage condition in the neutral position sensor B circuit of the Honda HRV model from 2016 to 2022. A high voltage level in this circuit can trigger the vehicle's safety protocols, potentially impacting the vehicle's ability to shift gears properly. The neutral position sensor is vital in informing the powertrain control module PCM, whether the transmission is in a neutral state or not, which directly affects the engine's performance and the vehicle's drivability. This code usually appears when there is an issue with the sensor itself or its connection to the PCM, including worn-out wiring or faulty connectors. In this presentation, we will delve deeper into the affected components, their roles, possible causes, symptoms, and a step-by-step troubleshooting guide to resolve the P1708 error efficiently. DTC P1708 refers to a malfunction within the neutral position sensor B circuit, which operates by detecting the neutral state of the vehicle's transmission. This sensor informs the powertrain control module, PCM, about the transmission position to ensure safe operations. The sensor is typically located near the transmission assembly, connected to the vehicle's wiring harness. The PCM, which is the vehicle's brain, processes input from the neutral position sensor to manage engine behavior and enable proper gear shifting. If the PCM detects an unexpected high voltage signal from the neutral position sensor B, it triggers the P1708 trouble code. Diagnosing this issue requires understanding both the sensor's functionalities and the related circuitry. Several factors can lead to the P1708 error code. The most common cause is a faulty neutral position sensor, which may have failed due to wear and tear over time or exposure to harsh conditions. Another potential cause is issues with the wiring in the circuit, which can affect the voltage readings sent to the PCM. This could include frayed or broken wires, corroded connections, or loose terminals within the circuit. Additionally, poor electrical connections between the sensor and the PCM can also lead to high voltage readings. Each of these issues should be systematically assessed when addressing the P1708 trouble code. When encountering DTC P1708, drivers may notice several symptoms that indicate a potential issue with the neutral position sensor B circuit. One primary symptom is impaired transmission performance, which may manifest as difficulty in changing gears smoothly. This can detract from the drivability and safety of the vehicle. Additionally, the vehicle's dashboard may illuminate a warning light, most likely the check engine light. Owners might also experience unexpected engine behavior, such as stalling or slow acceleration due to incorrect signals being sent to the PCM. Identifying these symptoms is crucial for timely diagnosis and repair, ensuring safe and efficient operation of the vehicle. The first troubleshooting step for addressing DTC P1708 involves verifying the problem to confirm a fault. Start by turning the vehicle's ignition to the on position to initialize electrical systems. Then, utilize the Honda Diagnostic System, HDS, to clear the current trouble code. After clearing, check for any pending or confirmed DTCs. If P1708 reappears, it confirms the presence of an issue that necessitates further investigation. If no DTCs are present, it might indicate an intermittent failure, suggesting that the system is operational at that time, but may require inspection of the sensor's connections and terminals for any loose or corroded areas. In this step, the technician must again check for pending or confirmed diagnostic trouble codes through the HDS. It is essential to determine if both DTC P0852, which relates to neutral position sensor A, and DTC P1708 appear simultaneously. If they do, Proceed to the next diagnostic step to examine the components involved intricately. If both codes are not present, this may warrant additional scrutiny of the vehicle's wiring or connectors to the sensors in question. Identifying the correlation between these codes helps pinpoint the specific fault, guiding the troubleshooting process effectively. In this step, one must start with turning the vehicle's ignition to the off mode. Once the vehicle is powered down, locate and disconnect the neutral position sensor's 4P connector. With the sensor disconnected, switch the vehicle back to the on mode to take necessary voltage measurements. Using a multimeter, measure the voltage between designated points on the sensor connector. Ideally, you should find a voltage reading of approximately 5 volts between these two test points. This reading is crucial. If you measure this value, it indicates a fault within the neutral position sensor itself, necessitating its replacement. If a correct voltage is not present, move on to further checks detailed in the following troubleshooting steps. In this process, you must start by turning the vehicle's ignition switch to the off position. Then, using the Honda Diagnostics system, jump the SCS line to trigger the required diagnostic conditions. Disconnect the PCM connector B, which is marked with a 51P configuration. Next, check for continuity between specific test points, the PCM connector and the neutral position sensor connector. If continuity is intact, it implies that the SG2 wire is functioning correctly. If there is continuity and the DTC still persists, consider updating the PCM software if it is outdated or substituting it with a known good component. If the DTC disappears upon completing these actions, it confirms the resolution of the issue. Otherwise, move to check for an open wire, as indicated in the following troubleshooting steps. To execute this step, ensure the vehicle is turned off. Again, use the HDS to jump the SCS line for diagnostic purposes. Once prepared, disconnect both the PCM connector B51P and the neutral position sensor 4P connectors. Power on the vehicle to the on mode and utilize a multimeter to measure voltage between specified test points on the connectors. Specifically, measure from the neutral position sensor, connector number 4, to the body ground. If any voltage is detected, it indicates a short circuit to power within the NSS2 wire, necessitating repairs on this line. If there is no voltage, proceed to verify the continuity of the NSS2 line in the next troubleshooting step. Begin this step by ensuring the vehicle's ignition is set to off. Disconnect the neutral position sensor 4P connector and the PCM connector B51P. Use a multimeter to check for continuity between defined test points between the connectors. If there is continuity, that suggests the NSS2 line between the PCM and the neutral position sensor is functioning as expected. However, if there is no continuity, the next course of action involves investigating for any potential open circuits. An open NSS2 wire would need to be repaired to ensure proper signaling in the system. If continuity checks out, advance to the critical PCM check in the following step. For the final troubleshooting step, start by setting the vehicle ignition to the off position before reconnecting the PCM connector. After reconnecting the PCM, connect terminals A and B using a jumper wire, facilitating the diagnostic process. With the vehicle back to the on mode, check the readings for the neutral position sensor B via the Honda Diagnostic system. Ideally, the readings should reflect around 0 volts under proper conditions. If 0 volts are indicated, it confirms that the neutral position sensor is faulty, requiring replacement. Alternatively, if the readings are not as expected, consider updating the PCM software or substituting it with a known working unit. Then continue monitoring to see if DTC P1708 clears. Upon completing the repairs associated with DTC P1708, a final verification process is vital for ensuring the system operates correctly. Start by using the Honda Diagnostic System to clear any stored DTCs. Following this, conduct a test drive of the vehicle to evaluate performance under normal operating conditions. Monitor for any warning lights or returning DTCs while driving to ensure the issue has been rectified. If DTC P1708 does not reappear and the vehicle operates without issue, it confirms successful repairs. Document all findings and repairs conducted for future reference and diagnostic integrity. Maintaining the Honda HRV to prevent issues like DTC P1708 involves proactive measures. Regular inspections of wiring and connectors related to the neutral position sensor can identify potential wear or damage before they lead to notable faults. Keeping an eye on the health of the electrical connections ensures a reliable signal to the powertrain control module. Additionally, ensuring the vehicle's software is up to date can aid in preventing operational issues, as manufacturers frequently release updates to rectify known problems. Following scheduled maintenance routines as outlined in the owner's manual also plays a key role in long-term vehicle reliability. In summary, addressing Diagnostic Trouble Code P1708 effectively hinges on identifying symptoms early and following a systematic troubleshooting guide. Regular diagnosis and maintenance can help prevent such issues from occurring. The step-by-step troubleshooting process ensures that technicians isolate the problem accurately, whether it's related to the sensor, connectors, or PCM, emphasizing preventive maintenance practices, such as regular inspections and software updates, helps to uphold vehicle performance and reliability. Ultimately, attentiveness to these aspects contributes significantly to the longevity and safety of the Honda HR-V. Please like and subscribe to the channel. See you next time!